Hey everybody, here's a solution, or two or three, to problem 2.13.14 in collaborative statistics. This involves couples and singles spending, it looks like, on a Mexican Riviera cruise ship. 60 single travelers indicated in the diagram, and also 70 couple travelers indicated. The first thing that problem asks you to do is to complete the relative frequency in the distributions that are in the book. Rather than doing that on the board and doing the histograms that they want us to draw at the same time, I just decided to put the relative frequencies on the individual bars. It's a little bit confusing color-wise, so I'll explain it to you. The red, or the pink, would be the relative frequencies of the singles. So 1/12, or 5 out of 60, because there's 5 of them out of the 60 becomes 1/12, or about 8%. Are spending between $51 and $100. 1/6, 17%-ish, are spending between 100 and 150, and so forth and so on. So your relative frequencies for the singles are the 1/12, 1/6, 1/4, 1/4, 1/6, and 1/12. The relative frequencies for the couples are these fractions here: 1/14 between 100 and 150. 1/14 between 200 and 250, 1/14 between 250 and 300. A little confusing here because it was the same raw number in 300 to 350, but it's 1/12 for the singles and it's 1/14 for the couples because there's different numbers of couples versus singles. And then 1/7 and 1/14. So it was easy to do fractions because they were nice, they were evenly divisible numbers, but honestly, percentages make more sense. Like I said, 1/6 is about 17. 1/7 is going to be about 14 and a half, somewhere around the 14%. So a 14th is about 7%. Yeah, ish. If you need more precision, you can use technology. So there's your relative frequencies. Part B, construct a histogram. Boom. Scale the axis by $50 widths. Boom. Use relative frequency on the y-axis. Well, I should have read that more carefully. Now, shouldn't I have? So let's fix it. Let's fix it. They want relative frequency on the y-axis. I indicated frequency, so that is not a big problem to fix. We'll just go up here and we'll put relative frequency on the y-axis, and I think I originally had it at 20. Right, 5, 10, 15, 20. So why not just call it, yeah, we'll just call this 20 out of 60. I'll just make it 1/3. Make this 1/6, then we can go from there. Yeah, that's going to be ish correct. I'm not perfect across here. The 1/7 should be lower because this is scaled more towards a 1/12 and 1/14 should not be the same height anymore. So I'll edit those two. Should have read that a little more carefully. My apologies. We'll knock them down a little bit lower to make them match a little more carefully. So we'll bring the 1/14 across here, the 1/7 across here, and the 1/14 across there. There we go. There, that's a little more accurate. Cool, there's your relative frequencies. Construct a histogram for the couples groups. Same thing, use relative frequency on the y. Compare the two graphs, list two similarities. Well, the first thing I kind of notice about the graphs being similar, and we may or may not have talked about this already in class, is that these are roughly, well, they're symmetric-ish. The blue one's perfectly symmetric, meaning if you split it down the middle, it folds over on itself. The yellow one is symmetric-ish. You've got some symmetry in this part of it, but then you've got this tail over here. So that's one similarity. Two similarities. If I had to find a second similarity, well, the percentages are roughly consistent. I mean, 1/6 and 1/7, 1/12 and 1/14, they're only off by 1 or 2 percentage points. So not that big of a deal there either. Two differences. Well, the overall differences obviously are that the couples are spending more money than the singles, and that, on average, that hopefully makes sense. You've got two people where you're comparing it to one person. So I think that makes sense. I mean, the center of this graph is at 200, the center of this graph is roughly at 4 to 450. Which is roughly twice as much. So you do have overlap, but there's definitely that difference there. The data is more variable in the couples. It's more spread out. There's a range of $50 to $350 or $300 for the singles, or there is a range of $100 to $650 or $650 for the couples. So not only do you have twice the average, you also have twice the variability if measured in range form. And the last one says, overall, are they more similar or different? I'll leave that to you. You can decide. Oh, one last thing to mention. I put both of these on the same set of axes. This looks much better when done with software like Excel or Minitab or SAS or SPSS. Also, I wouldn't have had the relative frequency issue that I had because I could just change the scaling automatically over here and it would update. So, one final tech note.